Okay, 5.8, the last section we're doing, inverse trigonometric functions integration. So basically we're going to have rules again. So there are your rules you've got. If you have, and remember du is the same as what?
U prime.
U prime, so if you want to just put u prime. You will see it sometimes they have the du written off to the side. They'll have like 1 over a squared plus u squared du. On page 385, it has a bunch of integration rules too, if you want to look at them. But I think I gave you a good exhaustive list.
What was that page that had?
385 has basic integration rules. Okay, we good?
Yep.
Okay, so when you write this down, you could write this as a 1 and dx, yes?
Yeah.
Okay. So the integral of 1 over the square root of 4 minus x squared dx.
Only use the first rule.
So u is what?
4 minus x.
Look at your, go back to your rules. Okay, our u is going to be,
1.
our u is going to be these.
Oh, well. Then wouldn't it be? Our u's gonna.
Our u is going to be in the denominator. So
With x squared.
so u is just going to be x squared.
X squared. Oh. And then u prime's 2x.
Okay, so u is x squared, so u prime is 2x.
Yeah. Would it be negative?
Wait, no, not x squared. No, and it's not negative because the rule is negative. Just say, I got this, I can't, oh, that's going to bother me. Okay. So u is just x, because the rule is x squared. Does that make sense?
Yep.
U is x, so u prime is 1. And that's what we have, isn't it? We have 1 and dx. So what rule gives me u prime? Oh, what's a?
4.
No,
1.
look at the rules.
2.
2. Because the rule says a what?
Squared.
So what rule gives you u prime over the square root of a squared minus u squared?
The first one. Arc sine.
Arc sine. Do you see that, Ainsley?
Yeah.
Okay, but do you see how we need to decide what u is, what a is, and that's where we're going to take the square root of those. Okay, so f of x would equal the arc sine, I hate writing arc sine, of u, which is what?
X.
X over a, which is
4. Or 2.
2 plus c.
So we really don't have to plug it into the u prime over a square. No.
You do, that's the pattern. That's what you're going to see what you have.
We just plug it into the arc sine.
Mm-hmm. Okay, so again, we have the integral of 1 over 2 plus 9x squared dx. So before we start, what's it look like?
It looks like the second one.
Looks like arctangent, right? Okay, so we need to decide what u is. Now, arctangent, the rule is u prime over a squared plus u squared. That's the rule, right?
Mm-hmm.
So we have to take the square root. So u would be what?
9.
You have to take the square root. So the square root of 9x squared is
8. I was about to say something not right. I caught myself.
3x.
Yes.
You got to take the square root of both.
So the u prime is 3.
So u prime is 3. And what's a? Got to take, no,
Or
because it's a squared, so it's the square root
of 2.
of 2. Now we're struggling with that, aren't we? We say, which one does it look like? And the rule is u prime over a squared plus u squared. So I have to take the square root of those things in the denominator. Okay, so it equals then, what is it? 1 over a arc tangent of u over a
Mm-hmm.
plus c.
Yeah.
Okay, so f of x equals,
1 over square root of 2.
so 1 over the square root of 2,
Arctangent.
arctangent,
3x over square root of 2.
3x over the square root of 2, and we are not leaving any of that like that.
Let's see.
It's gross. So we got square root of 2 over 2. My pen is not wanting to work. Arctangent of 3 square root of 2x over 2
Yep. Let's see.
plus c. I'm more worried about rationalizing the square root of 2 over 2 than the other, but if you're going to do one, you might as well do both, right? Good?
Yeah.
Okay. So again, 1, right? I don't like the dx in the numerator. It bothers me. If you don't mind it, go for it. But I will never write it there. Okay, so the integral of 1 over x times the square root of 4x squared minus 9. So we're going to try something a little bit different since we're struggling. Which one does it look like?
The third one.
The third one. So what is u squared?
It's gonna be. What do you mean u squared?
Because the formula is
U squared is.
the formula is u prime over
4x.
u square root of u squared plus minus a squared. Yes?
Mhm.
Okay, so that means u squared is 4x squared. So what is just u? 2x. Did that help?
Yeah.
Because you guys were struggling with that. Okay, and a squared is 9. So what's a?
3.
3.
Well, I can do that. It's just, it takes me a minute to look at it.
Okay. If that helps, do it. Okay. So then we need u prime, right?
2.
U prime is 2. Okay. Now, I'm going to plug this all in real quick. So this says, if it fits this rule right here, yes, I would have 2 over 2x, the square root of 4x squared minus 9. Do I have that up here? Do I have that up there?
Yeah.
Yes, I do, because these do what? Those reduce.
Yeah.
So sometimes are you going to have to plug it in to see? Yep. Okay, so now, then my rule was 1 over a, so f of x equals 1 over 3 arc secant. Of
U over
absolute value of u, but u is 2, so we don't need the absolute value. If u is a variable, you need 2. Oh, wait, u is 2a, not 2. I did a. Sorry. So it's 2x, so it's the absolute value of 2x. And do we have to have that? Yes, because x could be negative, correct?
Yeah.
Over a, which is 3. And my absolute value looks like a 12, doesn't it? No, it doesn't. Plus c.
I understand it. Saying this and then I'm looking crying later tonight.
Okay, well, sometimes. Oh. Okay, so what does this one look like? Remember, this e to the 2x is the same as e to the x squared, isn't it? Isn't that the same thing? Okay, so u would be e to the x. And then a would be 1. Square root of 1 is 1. Oh, what's u prime? Sorry, I didn't write it because u prime is what?
Yes.
E to the x. Do I have that?
No.
No, I don't, do I? Because I have 1 over the square root of. So, does that look like anything? It kind of looks like what?
The first one.
The first one, but not quite. So, what if I used substitution? Because it doesn't fit anything right now, does it? No, because I don't have e to the x in the numerator, and I have to have u prime. But what I can do is, using substitution, making u, I'm going to erase this. I can't stand that it says looks like that. Okay, so I'm going to make u be e to the x. So du would be what? E to the x. Dx. So my problem is I have this dx here that I don't have covered anywhere, do I? But guess what I can do? Can I solve this for dx? So dx would equal u prime divided by e to the x.
Then it would become 1.
No, we're going to use u. We're going to substitute u in here. So we now have the integral of u prime over e to the x, but what is e to the x? Isn't it u?
Yeah.
Isn't e to the x u?
Yes.
Okay, so u, the square root, well, e to the x is what again? U, right? U squared minus 1. Now which one does it fit? Now it fits arcsecant, doesn't it? So f of x equals 1 over a. What's a? 1. Arcsecant of the absolute value of x, which is u, because we changed it to u right here, over a, which is 1. I forgot my absolute value. Plus c. So we use substitution, so we have to go back, right? Well, 1 over 1 is 1. U is what? E to the x over 1. And we don't need our absolute value anymore because can e to the x ever be negative? No. So can we do some finagling? Yes. And you're like, we hope we don't do that much. I got one more example. That's all I got. Am I good? Okay, so the integral of x plus 2 over the square root of 4 minus x squared dx. Now that doesn't look like anything because we have a quantity in the numerator, don't we? But we can also rewrite things, we know, by the addition property. So I can take the integral of x over the square root of 4 minus x squared dx plus the integral of 2 over the square root of 4 minus x squared dx.
First one. So we don't.
Does that fit any of them?
Kind of the first one. But not entirely.
No. Well, the first one fits. Oh, what was
Doesn't
that?
The first one fit both?
The first one fits this, but it doesn't this one because of the what?
The X.
Because of the x. So what can we do with this? Let's do this one. Let's do the rule for the second part of it. So u would be x, correct?
Mm-hmm.
And u prime would be 1, and a would be 2. So we'd have to multiply by a 2 to get that 2 in there, wouldn't we? Like this 2 needs to come out here because it's 1. Okay, so we're going to do the first rule with the 2 out in front of it is basically what we're going to do. And the first rule is arc sine of u over a plus c, correct? So we're going to have 2. Why do we have 2 again?
Because we split them up.
Well, no, well, yes, but the 1 needed to be a 2, so you multiply by 2.
Oh, I thought you were meaning like why we have 2.
Oh, no, I'm sorry, the number 2. Arc sine of u, which is x, over a, which is 2, plus c. Okay, now we got to deal with that first one. Can't we just do the power rule? Because couldn't we rewrite this as x times 4 minus x squared to the 1/2?
Yeah.
And so then we would have u, we would make 4 minus x squared. So u prime would be negative 2x dx. So then we would have negative 1/2 to get rid of the negative 2, right?
Yeah.
The integral of u to the negative 1/2. Oh, du. I forgot my du, didn't I? So then add 1, divide. So if I add 1 to 1/2, I get 1/2, and then multiply by 2 then, right? So negative 1/2 times 2 u to the 1/2 plus 2 arc sine x over 2 plus c.
And then wouldn't it just be u to the 1/2?
So negative, and then we just replace our u, but yes. So the square root of 4 minus x squared plus 2 arc sine x over 2 plus c. So we had to use substitution 2 different ways, didn't we? But we can separate and make it easier rather than doing it all at once. Now, do you know why we're going to have a 2-day test? Because are these problems going to take you a minute? Are you going to try something and it not work and have to try something else?
Yeah.
Yeah. And that's all I got for today.